Welcome back to Midnight Curiosity. I'm Atlas, your guide through tonight's contemplative journey into 10 paradoxes that have puzzled humanity's greatest minds. These aren't problems to solve before sleep. They're invitations to wonder. So settle in, let your shoulders drop, and let's explore together. Chapter 1. The Liar's Paradox. Words that trap. Imagine a simple sentence, the kind that seems harmless at first. This statement is false. Now pause. Think about it. If the statement is true, then what it says must be accurate, which means it is false. But if it's false, then what it claims must be inaccurate, which means it's true. Round and round, a logical loop with no exit. This paradox haunted ancient Greek philosophers for centuries. Eubulides of Miletus first formulated it as a puzzle, and it refused to die. The medieval logicians of Europe spent countless hours wrestling with variations. Is language itself broken, or is our logic flawed? Some philosophers argue the sentence is neither true nor false, but a third category entirely. Others insist the paradox reveals a fundamental limit of what language can express. The sentence tricks us because it's self-referential. It bends back on itself like a snake consuming its own tail. The real puzzle isn't the words themselves. It's what they reveal about meaning. When we speak, we assume there's a stable foundation beneath our statements. We assume words point to something real, something consistent. But the liar's paradox shows that sometimes words can fold in on themselves and collapse the very ground they stand on. It matters because it challenges our most basic assumption that language can reliably describe reality. Some philosophers find this paradox frustrating, a mere trick of words. Others see it as a window into something profound about the limits of human reason. I find it worth considering how much of what we trust rests on assumptions we've never tested. Chapter 2. Zeno's Paradox, Motion Impossible. There's a race about to begin. Achilles, the swift warrior, stands ready. His opponent is a tortoise. But here's where it gets strange. Before Achilles can catch the tortoise, he must first cover half the distance between them, then half of what remains, then half of that, and on infinitely. How can he ever close the gap if there are always infinite steps remaining? Zeno of Elea posed this around 450 BCE, and it still unsettles us. The tortoise has a head start. Achilles is 10 times faster. But according to Zeno's logic, Achilles can never overtake the tortoise, no matter how swift his legs. Every finite distance can be divided infinitely. Every journey requires crossing infinitely many points. Our intuition screams that this is wrong. We see people run. We see them win races. Yet the mathematics seems airtight. Medieval thinkers tried to solve it through pure reason. Modern mathematicians found salvation in calculus and infinite series. An infinite sum of finite numbers can equal a finite result. So Achilles does catch the tortoise. The infinite steps take finite time. The math works. But something feels unsatisfying about this solution. Yes, we can calculate the moment of overtaking. But have we really explained how motion is possible? Have we solved the paradox, or merely shown how to ignore it? Zeno's true genius wasn't in creating an unsolvable puzzle. It was in revealing the strange gap between our experience of reality and our logical descriptions of it. The world moves. We see it every moment. Yet when we try to describe motion precisely, it becomes impossible. Why should there be such a rift between perception and explanation? This paradox shows us that the world refuses to be completely captured by logic alone. Some mathematicians see Zeno as an obstacle history surpassed. Others see him as a prophet who glimpsed something true about reality's fundamental nature. I find it worth sitting with the question of why motion, which seems so obvious, requires such elaborate mathematics to explain. Chapter 3. The Trolley Problem. Kill or let die. A runaway trolley barrels down a track. Ahead, 5 people are tied to the rails, unaware of the danger. You stand beside a switch, pull it, and the trolley diverts to a sidetrack. But there's a single person tied to that sidetrack. You can save 5 lives. You can do it right now, but only by killing one innocent person with your own action. Do you pull the switch? Most people say yes. Save the 5. The mathematics is simple. 5 is greater than 1. But here's where it gets darker. Imagine a different scenario. The same trolley. The same 5 people. But now, you're on a bridge above the tracks. Beside you stands a large man. You could push him off the bridge. His body would stop the trolley. 5 would be saved. 1 would die. The mathematics is identical. The outcome is the same. Yet most people cannot push. Most people recoil from the idea. Philosopher Philippa Foot created the trolley problem in 1967, and it has never released its grip on us. It reveals a deep tension in how we think about morality. We want to believe ethics is rational, that the right choice can be calculated. 5 lives versus 1. Simple arithmetic. Yet something in our conscience rebels against directly harming someone with our hands, even if it saves more people. The paradox isn't just about the numbers. It's about intention, action, and complicity. When you pull a switch, the trolley kills. When you push a man, you kill. The difference seems thin, yet psychologically, emotionally, morally, it feels enormous. Some philosophers argue that there is a real moral distinction between acts and omissions, between intended harm and foreseen consequences. Others insist this is an illusion, that we're simply uncomfortable with our own complicity. The truth may be that morality isn't as clean as mathematics. The trolley problem matters because every society makes choices like this. Healthcare decisions, war, disaster response. We must choose who lives and who dies, who receives resources and who does without. The question haunts us because we know our answers might be hypocritical. We condemn the push, but accept the switch, without being entirely sure why. It's interesting to consider how our moral intuitions often contradict each other, and how we rarely notice until someone presents us with the same dilemma in a different form. Perhaps the trolley problem's true value isn't in finding the right answer, but in recognizing how little we understand about why we choose as we do. Chapter 4. Schrödinger's Cat. Quantum Uncertainty. Picture a sealed box. Inside is a cat. Also inside is a radioactive atom, a Geiger counter, and a vial of poison. Here's the mechanism. If the atom decays, the Geiger counter detects it. The counter then triggers a device that breaks the vial. The poison is released. The cat dies. If the atom doesn't decay, nothing happens. The cat lives. Now comes the strange part. At the quantum level, particles exist in a superposition. The atom is both decayed and not decayed simultaneously until someone observes it. So what is the cat? According to quantum mechanics, until you open the box and look inside, the cat exists in a superposed state. The cat is both alive and dead at the same time. This is absurd. Everyone agrees it's absurd. Yet Erwin Schrödinger proposed this thought experiment in 1935 specifically because quantum mechanics seemed to demand exactly this kind of absurdity. He wanted to show the limits of quantum theory, to reveal how strange it becomes when you scale it up from tiny atoms to creatures we can see. The paradox isn't about the cat, It's about the bridge between the quantum world and our ordinary experience. The real quantum mechanics is far stranger than most people realize. Particles can be in multiple states. They can be entangled across vast distances. Light behaves as both particle and wave depending on how you observe it. The act of measurement changes the outcome. Reality at its smallest scales doesn't work the way our intuition suggests it should. This isn't poetry or metaphor. This is how the universe actually operates at the atomic level. Scientists have proposed solutions. The many worlds interpretation suggests that both outcomes occur, just in different branches of reality. The Copenhagen interpretation argues that the superposition is real, but our observation collapses it into one state. Others suggest quantum mechanics is incomplete, and hidden variables determine the outcome all along. But none of these truly resolves the fundamental strangeness. Schrödinger's cat matters because it forces us to confront the limits of our understanding. The universe operates according to rules that our minds didn't evolve to grasp. We're beings who see, smell, and touch. We expect objects to be either here or there, not both. We expect things to have definite states. The quantum world doesn't care about our expectations. Some scientists find this thrilling, a glimpse into reality's true nature. Others find it deeply unsettling, a hint that the universe might be fundamentally irrational or unknowable. I find it worth considering how our certainty about reality might rest on assumptions we've never questioned. Chapter 5. Ship of Theseus. What makes you you? There's a legendary ship in ancient Athens, preserved as a monument to the hero Theseus. Over the centuries, it requires maintenance. A plank rots, so it's replaced with new wood. Another plank fails, replaced, year after year, piece after piece, until finally no original wood remains. Every atom of the original ship has been swapped out. Is this still the ship of Theseus? Most people say yes. The ship has continuity. It's been in one place the whole time, maintained as a shrine. But here's where it grows complicated. What if the philosophers who removed the old planks had kept them? What if over time they assembled those original pieces back into a ship? Now you have two ships claiming to be the real ship of Theseus. One has continuity of location and function. One has continuity of material. Which is the real one? Or are they both? This puzzle, refined by philosophers like Thomas Hobbes and John Locke, reveals something unsettling about identity itself. We think we know what makes something the same thing over time, but identity isn't a fact written into the universe. It's a convention we've agreed upon. For ships, we usually care about continuity of function and location. For art, we care about the original materials. For people, we care about something else entirely. Now apply this to you. Your body replaces its cells constantly. In 7 years, most of your physical material will be different. In a decade, your brain has rewired itself through experience and learning. Your memories fade and change. Your beliefs evolve. Your personality shifts. If everything about you is gradually replaced over time, are you still you? What makes you the same person you were 20 years ago? Is there some unchanging essence at your core? Or is your identity an illusion, a story you tell about continuous change? Philosophers have proposed many answers. Some argue for psychological continuity, that what matters is the chain of memories and beliefs connecting your past self to your present self. Others argue for bodily continuity, that the continuous existence of your body is what makes you you. Some propose a more mystical view, an unchanging soul or consciousness that persists through all physical change. None of these answers is entirely satisfying. The ship of Theseus matters because it asks something we rarely articulate. What do you think you actually are? If your doctor replaced your heart, you'd still be you. If they replaced your brain with a perfect copy, would you still be you? If they did it gradually, replacing neurons one by one, would there be a moment when you stopped being you? These aren't merely academic questions. They touch on what philosophers call personal identity, and they have implications for how we think about survival, death, and what we truly value about existence. It's interesting to consider how much of our sense of self rests on the assumption that we persist as a unified being, when actually we're more like a pattern that's constantly changing. Perhaps identity is less like a substance and more like a song, which remains the same song even as new notes replace old ones. Chapter 6. Brain in a Vat. Is reality real? Imagine a mad scientist. She surgically removed your brain. It floats in a vat of nutrients in her laboratory. Electrodes connect to every neuron, stimulating them with precise signals. These signals create the illusion of a body, a world, other people. Everything you're experiencing right now, this moment, might be nothing but electrical impulses in a disembodied brain. You can't know it's happening. The scientist is too skilled. The simulation is perfect. Your memories, your sense of self, your experiences, all of it seems real because it is real to you, subjectively. You have no access to reality outside your own mind. You can only be certain of your own thoughts. Descartes said it centuries ago. I think, therefore I am. You know you think, but you don't know what creates those thoughts. You don't know if the external world is real. This is the brain in a vat scenario, and it's a modern version of ancient skepticism. Descartes himself used it as a thought experiment. More recently, philosopher Hilary Putnam updated it. He asked, even if you are a brain in a vat, when you think the word vat, what does it refer to? It can only refer to the vat as it appears to you, the simulated vat. But that's not a real vat. So you couldn't be thinking about a real vat. Therefore, you can't be a brain in a real vat. It's a clever argument, but it doesn't quite settle the matter. The question lingers. Could the scientist create a scenario so perfect that your doubt becomes indistinguishable from knowledge? This paradox matters because it challenges the foundation of everything we think we know. Science rests on observation and evidence, but all observation is mediated through your nervous system. All evidence is interpreted by your mind. You can never step outside your own consciousness to verify that what you're experiencing actually corresponds to reality. You take it on faith. You assume the external world is real because it's useful to assume so, because other minds seem to exist and confirm it. But the assumption could be wrong. Some philosophers dismiss the brain in a vat as a useless puzzle, a game that has no bearing on how we live. Others see it as revealing a profound truth about human knowledge. You cannot achieve absolute certainty about external reality. All knowledge is ultimately based on what philosophers call foundational beliefs, starting points you accept without proof. Whether you accept that the external world is real, or whether you accept skepticism, you're making a choice that logic alone cannot determine. The brain in a vat matters because it reveals the limits of reason itself. We want knowledge to be objective, independent of observers. But all knowledge is processed through minds. This doesn't mean reality isn't real. It means something more subtle. The gap between reality and our knowledge of it is unbridgeable. We're always interpreting. We're always making assumptions. Absolute certainty is impossible. Some philosophers find this conclusion liberating, freeing them from the pursuit of impossible certainty. Others find it deeply disorienting, like standing on ground that's always shifting beneath their feet. I I find it worth sitting with the recognition that certainty is less important than wisdom. Chapter 7. Newcomb's Paradox. Predict your choice. An advanced being appears before you. This being can predict your choices with perfect accuracy. It's been right every time before. It presents you with two boxes. Box A is transparent, and you can see it contains $1,000. Box B is opaque. The being tells you, if it predicted that you would take both boxes, I put nothing in box B. If it predicted that you would take only box B, I put $1 million in it. Now, you must choose. Take both boxes or take only box B. This paradox, created by physicist William Newcomb, reveals a conflict between two different ways of thinking about rationality. From one perspective, the choice is obvious. The being has already made its prediction. Either box B contains money or it doesn't. Taking both boxes guarantees you get at least the $1,000 in box A, plus whatever might be in box B. So rationally, you should take both. But here's the problem. If you take both boxes, the being's prediction becomes true. You are the kind of person who takes both boxes. The being already knew this. It predicted that you would, so it put nothing in box B. You end up with $1,000. But if you had taken only box B, the being would have predicted that too, and it would have put $1 million inside. You'd be left wishing you had chosen differently. Some philosophers insist you should take both boxes because the past is fixed. The being's decision is already made. Your choice now cannot change what's already in the boxes. Others argue that you should take only box B because that's what rational agents who understand the setup would do. The being predicts this, and you end up with $1 million. The paradox reveals something profound about decision-making and causality. In normal situations, your choices affect future outcomes. But in Newcomb's setup, the being's past decision depends on its prediction of your future choice. You have a kind of causal power backwards through time. Your choice doesn't change what's in the boxes, but it was always going to match the being's prediction. The question becomes, should you choose what's rational given the past, or should you choose what causes the best outcome? Different philosophical traditions give different answers. Causal decision theory says, take both boxes, because your choice can't affect what's already decided. Evidential decision theory says, take only box B, because your choice is evidence of what's in the box. The paradox matters, because it reveals hidden assumptions in how we think about choice and causality. It's interesting to consider how our understanding of rationality breaks down when the rules of causality seem to bend, when our choices become evidence of causes rather than effects. This paradox suggests that rational choice might be less straightforward than we assume. Chapter 8. The Gettier Problem. Lucky Knowledge. Knowledge is justified true belief. Everyone agrees. If you believe something, and that belief is true, and you have good reasons for believing it, then you have knowledge. Simple. Philosophers thought this definition was settled, until Edmund Gettier wrote a short paper in 1963 that shook everything. Imagine a scenario. Your friend says he'll pick you up at 3 o'clock. You've known him for years. He's reliable. You have good reason to believe he'll be there. You believe it. You have justified belief. But unbeknownst to you, your friend had a flat tire. He won't make it. However, by sheer coincidence, a different friend who was driving nearby also decided to stop by at 3 o'clock. When 3 o'clock comes, a car pulls up. It's not your original friend, but your other friend. You're picked up at 3 o'clock exactly as you expected. Did you have knowledge that you'd be picked up at 3 o'clock? Your belief was true. You were picked up. You had justification, good reasons for your belief. Yet it feels wrong to say you had knowledge. You were right by accident. Your reasoning led to the correct conclusion, but for the wrong reasons. The definition of knowledge as justified true belief seemed airtight until Gettier showed how luck could sneak in. The Gettier problem matters because it reveals that knowledge isn't merely a combination of ingredients. Something else matters. Some philosophers argue that your belief must be reliably caused by the truth. Others argue that you must not merely be accidentally right. There must be a strong connection between your reasons and the reality they describe. But defining that connection precisely has proven remarkably difficult. We've tried for 60 years, and we still don't have a universally agreed upon solution. This paradox challenges our understanding of what knowledge actually is. It suggests that truth, belief, and justification aren't enough. There's something more, something like a requirement that your mental state be appropriately connected to reality. But what is that requirement? How do we define it? When does luck corrupt knowledge? And when is it merely background chance that we all accept? The Gettier problem matters because knowledge guides our actions. If you think you know something, but that knowledge is merely lucky, you might act on false confidence. You might make decisions as if you have reliable information when you don't. This suggests that what we call knowledge should be something stable, something we can depend on. Yet reality seems to allow for justified true belief that lacks that stability. The gap between knowledge and lucky truth proves harder to close than we'd like. Some philosophers find the Gettier problem frustrating, a mere logical puzzle with little real-world relevance. Others see it as revealing something fundamental about what knowledge requires. I find it worth sitting with the realization that what we're confident we know might be less stable than we assume. Chapter 9. Bootstrap. Paradox. Creating from nothing. Time travel. For a moment, imagine it's possible. Here's where it gets strange. You're a time traveler who travels back to the 19th century. You bring with you the complete works of Beethoven, all his symphonies written in his own hand. You find the young Beethoven and give him these manuscripts, telling him these are his own works that he'll write in his lifetime. Beethoven then spends his life copying the pieces from the manuscripts you gave him. He becomes famous for creating them. He lives out the exact life the manuscripts predicted. But here's the paradox. Where did the compositions come from originally? You got them from Beethoven. Beethoven got them from you. Neither of you created them. Neither of you can claim originality. The information exists in a loop with no beginning point. The works were never created. They always existed, bootstrapping themselves into reality through time travel. This is the bootstrap paradox, named after the phrase, "pull yourself up by your bootstraps," referring to doing something impossible. Various science fiction stories have explored it. In Harry Potter, Hermione uses a time turner to attend classes twice, and her knowledge of future events creates a causal loop. In Primer, a film about time travel so complex it's nearly incomprehensible, information loops back on itself. The bootstrap paradox reveals something unsettling about information and time. In normal experience, information is created. Someone invents something, discovers something, writes something. The act of creation happens at a specific moment, caused by choices and effort. But if time travel exists, you could theoretically retrieve information from the future and bring it to the past, allowing someone to merely reproduce what was already transmitted to them. This violates what we might call the conservation of information. Where does the novelty come from? Where does the original thought, the original creation, originate? The paradox suggests that either time travel is impossible or information can exist in a way that doesn't require creation. It can simply loop eternally. The Bootstrap paradox matters because it challenges our understanding of causality and information. We assume that things must be created before they can be copied. We assume that novelty must enter the universe from somewhere, through some act of imagination or discovery. But a Bootstrap scenario suggests this assumption might not hold in a universe that allows time travel. It raises the question, is information fundamental to reality, like matter and energy, or is it created by minds and brains? If information is fundamental, could it exist in loops? Could the universe contain information that bootstraps itself into existence? Some physicists dismiss the Bootstrap paradox as revealing merely that time travel is impossible, or that such paradoxes would be prevented by some unknown law of physics. Others find it philosophically fascinating, a hint that our understanding of causality is incomplete. I find it worth considering how much of reality we take for granted rests on assumptions about the nature of time and creation. Welcome to the end of tonight's journey. We've traveled through 10 paradoxes that have haunted humanity's greatest minds. The liar's paradox showed us language trapping itself. Zeno taught us that motion is stranger than it seems. The trolley problem revealed contradictions in our morality. Schrödinger's cat hinted at quantum strangeness. The ship of Theseus asked us what makes us ourselves. The brain in a vat challenged what we can know. Newcomb's paradox bent our understanding of choice. Gettier showed us how luck corrupts knowledge. Bootstrap reminded us that time might not flow as we imagine. And Mary's room left us wondering what experience truly is. These paradoxes won't solve themselves. They're not meant to. They're meant to sit with you, to work quietly at your assumptions, to remind you that the world is far stranger and more wondrous than our everyday routines suggest. Let these questions drift with you as you settle into sleep. They're not problems to solve. They're invitations to wonder. Rest well. This is Atlas, signing off.